right, we've already discussed these in class once, but in concern to this chapter, section 7.1, we're going to discuss quadratic functions again. Now, the general form of a quadratic function looks like f of x is equal to ax squared plus bx plus c, but those are a little complicated for our taste right now, and so we're going to just be dealing with the ones that look like f of x is equal to ax squared plus c. So we're going to learn a few things about the quadratic function. First of all, we're going to learn about the numeric coefficient of the x squared value. When we see the numeric coefficient of the x squared value, we're going to know what our function does in terms of being what we call increasing or decreasing. Now, first of all, we need to know that when we see a second degree function, that we are always going to see a parabola. And a parabola, remember, we've talked about this before, is a U shape. So we have u's that face up, or we have u's that face down. And when that a is positive, then we're going to have one that faces up. And when our a is negative, that parabola is going to face down. It's going to be a decreasing function. And then the next thing that we want to talk about is the vertex of this parabola. So either vertex here and here. And when we have a form that we just have the ax plus c, this vertex is at 0c. No matter which one we're looking at, it's at 0c. And that's quite nice because it helps us to graph these things quite quickly. Now this vertex, it has a special thing about it in these parabolas. You see, when we have an upward facing parabola, it's the minimum value. So we call it the min, or the minimum value, in the entire parabola. Now when they're facing downwards, it's also special. It's the maximum value, right? The max, or the maximum, which is the largest value that this function is going to take on. And those are some of the things that your book brings into light in this section as well. Now remember that we talked about before the line of symmetry as well, which is a vertical line that runs through the vertex of a parabola. And the line of symmetry is nice because the distance from the line of symmetry to the parabola is the same on both sides of the vertex. And so once we know what the axis coordinate of the vertex is, then we can find values on either side of that by using the fact that it's symmetric. So let's go ahead and take a look at an example of a parabola. Let's take a look at the y equals negative x squared plus 2. Now we can always plug and chug with these. If you remember what we did before when we were looking at parabolas, we were going ahead and saying, okay, well, we'll just put in values for the x and solve for the y, or in our case these might say solve for the f of x. But remember that that wasn't very good unless we knew what the function was going to look like. So now we can see that this is a second degree function, so it's going to show us a parabola. We can also look to see that this is a negative x squared, and so we're going to know that we're looking at a downward facing parabola. The next thing that we can also look at is that we have the vertex here at 0, 2, and then we can find some symmetric points at that. So let's go ahead and put in our vertex at 0, 2, right there. And then what we can do is we can plug and chug with some values. Now because our parabola is centered around the y-axis, we can put in values that are both positive and negatives of the same number, and we know that the y's will be the same. That's that axis of symmetry acting for us. So when we put in x is equal to 1, what we're getting is the opposite of 1 squared and then plus 2. So we're getting a negative 1 plus 2, which is a positive 1. And what we got there, we will also get when we put in negative 1. And then we can do the same thing for 2. So we would have the opposite of 2 squared plus 2. And when we get this, this will be a negative 4 plus 2, and that's going to give us a negative 2. And whatever we got for positive 2, we'll also get for negative 2, and that's the symmetry. And with these 5 points, we can plot it, and you'll see that in the next video.